to be mindful of time. So I will just say thank you very much for joining us for our penultimate.
I have to get headphones in or something because.
Hang on a second. I'll work on doing some muting here. Okay. Thank you for joining our penultimate showcase. I know that y'all's time is very valuable, and I hope that you found value in our other showcases so far, if you've been able to attend those. If not, you can find their recordings on the website. But we're very excited to have you with us today. We have just a couple of other points to cover here. So today is our next to last, as I mentioned, showcase. So we'll have one more tomorrow in this same time slot. Today we are meeting with Purdue and Streamworks, and we'll let them talk a little bit about their programs and what a partnership with them might look like here in just a minute. My name is Law Loving, as you can tell, and I'm with the Niswonger Foundation. Probably a lot of you have heard from me at some point, but if not, I work on the STEM.LD grant, particularly with our partners. There are some other folks with the foundation here as well. So there's several of them there on Brachet's camera and screen. Dr. Vicky Kirk and Ramona Williams, and also Brachet herself are there. So quite a few of us. And then we have Greg Striml from Purdue, and also Dennis Courtney from Streamworks. So a good crew here on our end. If you guys have questions as we go along, feel free to drop them in the chat. You can send them to our partners as well as foundation folks, and we're happy to help navigate the conversation there. We do want this to be a conversation, so do feel free to ask questions along the way. The last point that I'll make before we get started, and we'll have Purdue lead us off today, will be that there is an attendance form. So we do require that each school send at least one representative to each of these showcases. We just want to make sure that the information for all of the partners is being heard. And so there might be multiple representatives from a school, but at the very least, we need one representative from each school to attend these. We'll drop the link to the attendance form in the chat at the very end of this, and I'll throw it up on the screen for anybody that is watching this as a recording. Do make sure that you fill that out if you would like to get credit for having attended. Otherwise, we'll be pestering the folks or the schools that haven't had a chance to attend. We'll be following up with them to make sure they get all of the information. So stay tuned until the end. We'll drop that in at the end of both presentations. That's it for me for the moment. So let me kick it over to Dr. Greg Striml from Purdue, and we'll let him talk a little bit about Purdue's partnership with STEM.LD.
All right, thank you, Law. Can you see my screen and hear me all right? Okay, I got a thumbs up. So you have to minimize a little bit of that. Okay, so I'm Greg Striml. I'm assistant professor of engineering technology, teacher education here at Purdue. So I'm just going to give you a little bit of an idea of what we've been doing with some of our partner schools now and what we plan to do if as more kind of join along with us. So with our program, really what we've been focusing on is we just call it empowering the E in STEM. So really focusing on that engineering component and helping to cultivate engineering literacy for all students. So that's a little bit of the big idea, but our goal is overall is to just help to make engineering a part of every child's education experience by providing a toolkit. And I have it in parentheses for toolkit because we provide some resources, curriculum, planning information to help develop engineering focused lessons and things like that. But we also literally provide a toolkit that we send out to the schools for the instructors to use and to take with their students as well. So, and with these toolkits, I guess I'll say, we're looking to empower teachers to engage students and really support authentic engineering curriculum instruction and connecting that with other subjects, right? So whether it be with the CTE side and also science instruction, it kind of covers there as engineering is naturally integrative in that way. So when we talk about giving every child this opportunity for engineering learning, we really look at having three dimensions to that. So we want to help children orient their ways of thinking by developing engineering habits of mind. So things like systems thinking, creativity, optimism, conscientiousness, those type of habits of mind. We also want to help them competently enact engineering practices, covering things like engineering design, quantitative analysis, processing of materials and professionalism. But then we also want to work with them to appreciate, acquire, and apply, when appropriate, engineering knowledge that's scientific, mathematical, technical in nature, to confront and solve problems they encounter. So we realize they're not always going to need that information, but they need to know that it exists and how to use it when appropriate. And that's kind of what we're trying to do. So just a quick background, why do we really focus on engineering? Again, I mentioned this, so it is naturally integrative. So you can't really do engineering without tying to all the other subjects, and not just math and science, also bringing in the cultural elements, English language arts, those type of pieces, all are kind of required as we do that. Engineering projects and learning opportunities can tie to personal interests of students. So hopefully it can make, learning more relevant as well. And also, we always hear these workforce needs of people who are problem solvers and things like that. Well, what does it mean to really teach problem solving well? And I think that's where engineering can come into play. So it can link to some of these workforce needs that we continuously hear. And then another piece is it has been a historically exclusive area. So we want to broaden participation and access to engineering as we're bringing that into our classrooms. So just a little bit of my teaching background. So I used to teach, I prepare future engineering technology teachers now, and I do research around, engineering learning at the K-12 level. But when I was a high school teacher, it was just around the time when engineering was kind of first becoming big in high school. And I was responsible for our engineering CTE programs, as well as our general engineering classes that we started doing. I was teaching in Maryland there, and I had to work really hard to find kind of the content to teach and what was authentic. Because the last thing I'd want to do is kind of, teach, introduce something called engineering that wasn't really accurate, and people make career decisions and form perceptions around that, based on my knowledge. So I had to work really hard to figure out what that meant. And as I looked around, you could see some of the traditional kind of engineering activities in school, like building a bridge, smashing it, put the most weight on it. And, you could see that over and over again across multiple levels without kind of increased sophistication in the practices that the students were doing. So that really led me to focus kind of my career around engineering learning and providing guidance for that. So in talking with some of our partner schools before we started last fall, we figured out there was a couple objectives that people were interested in. Hopefully this is something you're all interested in as well. So we really just wanted to explore deep student engagement with rigorous engineering learning. So how can we do that, get some depth in some of the content and practices that we want to address, but also then integrate smart technology for developing more authentic engineering learning activities. So kind of what's the content, and then how do we do some really cool stuff with some technology that we can bring in. So that's kind of what we focused on. So I tell the partners, what are we going to do? So first of all, again, we're going to provide a toolbox, which you see in the picture, and that's just part of it. That's an older one. We actually expanded upon it. We want to provide a toolbox and some curriculum. So some of the technology we can use, but also some curriculum that we've been calling Build Smart. So these are things that we develop. We are not a program ourselves. I just prepare teachers, and we have some resources to share out where we can actually bring that technology in and do some things with it to be more authentic. And then through our partnership, we offer some sessions. So in the fall, we pick one of the activities, and we've met across schools. We meet virtually, but we send the kits out ahead of time. We offer 3 sessions for each kind of project, about 3 hours in length, that we kind of collaborate with the schools and go through the process. And I'll show you the projects we've done so far, so that way everybody can take those kits and implement it with their students, but also develop their own lessons from it. But then we'll provide all the resources. We have some grad students to help out, so and connect with the teachers and the students as well. So don't be afraid to reach out to us and get some connections as well to support some of these activities. So when I talk about kind of that build smart area, one thing we've done was a build smart smart buoy. So you'll see that on the right side of the screen. We're going through that now with a few schools. So we can actually figure out how to design, 3D print, produce, and then integrate some of the electronics component and sensors. So we can put a buoy out there and we can detect different types of data and use that to inform design. We've done electric vehicle kit as well, to how to design and do that and program it so we can control the motors and pieces like that. And we're trying to tie that locally to some connections in Tennessee, and I can share that out as well. Again, there's some other pictures. We also have an activity where we do a build smart clubhouse, so kind of an automated clubhouse that they can build and model. So taking some of these traditional activities you may have seen in classrooms, but kind of bringing in a computational thinking element of it, where we can collect data and use that data to inform design. So then we can become kind of more authentic in our engineering and science practices as well. So I'm just going to share out real quick kind of the spring session. So we're meeting again, we have 3 sessions and everybody's welcome to join, even if you want to jump in. We're figuring out some entry points if you missed the first session for the spring. So these are some pictures of how we do it virtually, and they're showcasing some of their the work that they're doing in the programming element. So we really like our little micro bits here, if you haven't used them before, to kind of bring in that sensor and computational element to our projects. So some of the teachers are showcasing the work to us virtually. Now, we love to be there in person, but actually working across schools, it actually made it a little bit easier to do that. So just to start, we look at empowering the E in STEM as an introduction, and we provide a framework that we created in partnership with the American Society for Engineering Education, helps define some of the content to teach and how to scaffold it. It's not designated. It's not saying this is what you have to do. It's just, hey, if you need something to do problem framing and dive a little bit deeper, so students know how to frame a problem, and as they begin to come up with a solution to it, we've developed some resources to go along with it to be used as kind of a menu for teachers. So we share that as a helpful piece. We also do some quick examples of how to bring that into something relevant, and we just pick something at the time and use that as an example. So there was a news article about the digital umpires in baseball, in the not the professional league, but how they were using those. So we figured, okay, well, let's use that as a context, bring in some of those concepts and just run through it with the teachers on the spot. And we programmed our own digital umpire using our microbits there. And it was kind of fun to do. It's just like a little intro activity to see how you can bring these concepts in to make them relevant. So this spring, we're going through this first session. We already jumped into how do you bring computational thinking into design when you're creating solutions? How can we connect to sensors and data collection elements to build and produce a smart buoy? And then we gave the challenge, of the purpose of doing that is so we can detect hurricane patterns. So we're bringing the science teachers this time as well. So how can we use that type of data and put it out there? And it'll send the data back to us and collect that. Then we go over modeling and prototyping. So how to use tools, right? We have a Dow caliper in there, how to use some design, computer-aided design tools as well. And we'll bring it together and we test it out to see how we can bring the programming computational side to that activity, and then how they can take that with their students. And then we go over our planning materials to say, okay, now if you want to take a context and do it yourself, go ahead and do that. And we'll help develop lesson seeds with them for things that they may want to do as well. So that's an example on the screen, and we have all those resources. And I'll just be quick to run through the fall session, which we did last fall. Same type of thing with going over the framework. The little activity we did there was, whether it's frustrating or not, it was around the social distance lanyards. We said, okay, well, let's use these and we'll program them for radio frequencies. So it'll keep everybody wearing this device will keep them 6 feet away. So just something fun we ran through pretty quick with them. But then we went into designing and 3D printing electrical vehicle that they can control. Kind of tied that into local racetracks, how they can go through and build that, program headlights, taillights, a variable speed motor on that, and then collect data from it on the improving the efficiency of that electrical vehicle as well. And then again, how do you bring that into your own lessons? So we have a bunch of resources to share with that, some projects and activities that you can take. We're recording each one of our sessions, so you can do that as well. And we have some examples now from the fall, the teachers using the kits with their students to do the micro cart, the smart micro cart, and hopefully we'll have the smart buoys with the kids coming up after our next couple sessions this spring. So I'll stop talking there. I know that was a lot, but I'm going to stop sharing my screen and I'll answer any questions you may have.
So we do have a few minutes for questions here for sure. And if you want to come off mute and ask a question, you are welcome to do that. If you are of the shyer variety, then feel free to drop things in the chat. Keep in mind that partnering with Purdue or any of our other partners, Streamworks as well, who you'll hear from shortly, is all included within the STEM.LD grant. So the things that Greg is showing here, you or your fellow teachers or other folks at your school would have access to, and we're helping to make sure that you have access to the carts and the other kits free of charge, in addition to Greg and his team's time and expertise. So we definitely want folks to take advantage of that. Greg, were you going to add something there?
Yeah, I was just going to say it's a great point. We just, when we have a partner, we ask what teachers are coming and how many, and we pack up the kits enough so that they could take them with their students, and we ship them out. We even made one mistake this last time where we forgot one resistor in there, and we had them out in the mail the next day, and we're able to do it. So it was a lot of fun, and we have some support to provide the teachers as well as for their time as they go through that.
So while we're waiting on maybe a question or two to pop into the chat, I was going to ask about, okay, great question from Andrew here. So I haven't led this type of thing before. It sounds a little intimidating. So how, I love the way you put this in quotation marks, idiot proof, are the kits, et cetera. I would have a similar question. So go ahead.
Yeah, so that's a great point, because we want to push towards kind of that authenticity and bringing in the computational element for some of the activities, but we walk through it, step by step. That's why we do right now, because it works with the schools we're partnering with, the 3-hour sessions that we do, and we do 3 of those, and we walk through it step by step, because even working with our little microbits here, the entry point is very low, but you can take the ceiling of it very high. So we won't leave you hanging. We're gonna walk you through it so that way you're comfortable to do it with them. But we've also used all these microbits with things as low as elementary school, so we can get there. And it sounds intimidating, but it's not that difficult, and we're there to help you with it. And provide you all the guides too.
Greg, I think it may be helpful, a couple of other pieces that may help folks with their frame of reference. One would be, STEM.LD being middle school and high school. Which grades are you open to working with? And then the other one would be to talk just a little bit about the time commitment involved. So I know you talked about sort of the cadence and sequence of multiple get-togethers and multiple steps in the process, but maybe give folks an idea of each step along the way and kind of what the time commitment would be.
Yeah, absolutely. So right now, we were trying to play around with this through the fall and into the spring. What seems to have worked really well so far is to set up those sessions we start in the morning. So it goes about kind of a half a day, and we've done it for 3 days. We try to do it kind of outside school times, but it gets a little bit iffy. It actually worked better to go during the school day for that section. So it's about, 3 hours for each one of those sessions and for each project. So this spring, we're doing the Smart Buoy project. So that would be 3 sessions. And then in between there, we do have a little bit of homework, which we assign as the kind of the out of school time, which we provide a stipend for currently. And that's where there's a little bit of stuff to get done in between, but honestly, it should be anywhere less, probably less than 2 hours max in between the sessions, which we have multiple weeks in between sessions too. So that's kind of the time commitment, but then we would hope that you take that and then implement that with your students. And we are there to help you with that. So you can do that as much as you can, given the resources that we have too, right? So, the amount of kits, we've had schools asking for extra ones. I mean, we do have a budget, but we'll try to get as many out there as we can.
All right, and middle school and high school, right? So this is
Oh,
an
yeah,
opportunity
sorry.
for either. Yeah.
Yeah, so actually like I mentioned, kind of the entry point with some of the things we use can be pretty low. And if they've never had any experience with programming, you can kind of jump right in with middle school. And it's kind of no different if they're high school and they had no introduction to block programming, because we just do block programming to start. But there's some options to do more if you want to do Python or JavaScript or anything like that. But we just really run with block programming. So we can do some of the activities across levels, and we have some ways to scaffold that accordingly. So middle school, high school works either way.
Very good. Very good. Very good. Other questions for Greg? I'm trying to give a long pause here. So if anybody has anything else, because we had a good one there. So I would say, yeah, exactly. I would say if you've got questions for Greg, you can also just should be able to just chat with him directly, and he can hang out for the next little bit. So if you think of something afterwards, definitely feel free to ping him on that. I'm going to turn it over now to Dennis Courtney. And Dennis, you're coming to us from Streamworks. So I think you should be able to share your screen. We've made you a co-host. So I'm going to let him tell you a little bit about Streamworks and what Streamworks has as part of STEM.LD. And again, just keep in mind, we know that you may or may not be the person that's going to interact directly with Purdue or with Streamworks, but if you have somebody at your school that you think might want to see this information, there's going to be a recording, and we would ask you to certainly circle back with your teams at your school. Greg's dropped his email in the chat, so if you want to email him directly, you can do that as well. All right, Dennis, you're up. Take it away.
All right, thanks, Law. Can you guys see my screen okay? I got the Nicewanger Streamworks. I'm Dennis Courtney. I'm the executive director of Streamworks. We are a nonprofit, been around since about 2017. Our scope is to bring in the extracurricular part of STEM education into the communities, because we're of the belief that our 75% of kids that are involved in extracurricular activities tend to go on to post-secondary education, which equates into good citizenry, jobs, and so you guys get all that, right? Because I'm talking to educators. So thank you first and foremost for the contributions that you make to these kids. We do serve K through 12. Primarily though, as Dr. Striml was talking about, if you can catch kids in that middle school area, man, I'm telling you what, that's where you can really have the most impact. So a little bit of our programming and why we do what we do. I don't think I need to go into a lot of detail about why we do what we do, but just some of the interesting stats that are out there. Over 1 million computer programming jobs went unfilled in 2020, and we're in 2022, and the outlook's not getting any better. Just looking at when does the average American adult finally settle into their permanent career, and that age is 33. We need to back the train up just a little bit and start getting these kids ready for their permanent career 10 years, a decade before. So that's some of our progress that we try to make, is getting kids pointed towards STEM relevant careers. And we believe that's what Streamworks is. We got a little bit of a niche for it. I'm not saying that we're perfect, but we are learning, and we partner with some really cool folks. Specifically MATE, Marine Advanced Technology Education, where we take robots and we put them into the pool, and we come out with all kinds of cool, challenging annual scenarios and theme challenges where teams come from all over. We currently have a competition up at the Appalachian Highlands Regional, which is with our other partner, East Tennessee State University. But why do we do all this? Well, these teams are forming up just like a corporation. They have a CEO, they have a CFO, they have to get up and do presentation skills, presentation for in front of judges and judging panels. I appreciate what Dr. Striml was saying, that, it's not all about the math and science, although we know that, man, I tell you what, we need to teach kids more applied math than ever before in today's world. But it's also about English language arts and getting up and doing those soft skills that a lot of people talk about, and just teaching kids, that, hey, show up for a professional presentation. No, you should not wear house shoes to work, that kind of stuff. So anyway, and this goes, we're not uncovering anything that hasn't been known for centuries. Going back to the old days of professors, the professors would stand in the communities and profess to the young people of the knowledge that they had to hand down. This is essential for any community to flourish and have good citizenry. So again, MATE, which is so economical. You take a robot, build it out of some PVC frame, and throw some motors on it, and charge $50 for a registration fee. And now you have a team that goes to a pool sometime in the springtime, and the kids have a great time. They get to show off their their invention. They get to show off a marketing display, and they get to talk about themselves in front of a judging panel. And it's really powerful. That impact, that's a culminating experience for those kids that have worked 3 to 4 months beforehand, trying to get themselves ready for that class of competition. That's what it's about. It's about the journey, getting them there. So some of our events are up here on the right-hand side of the slide, where you'll see the Artesian City Regional down in Georgia, Memphis, Chattanooga, the Appalachian Highlands might be in your neck of the woods. It's at East Tennessee State University on May 14th, 2022. And then again, the World Championships are in June of 2022, and those are located in this year. This coming championship is in Long Beach, California. So probably, if you guys have heard about the MATE program, we have several high schools in the Northeast Tennessee and Southwest Virginia corridor that are involved in MATE. So very probably one of the more predominant competitions that you'll see in the world is right there in Johnson City, Tennessee. So really cool. Our other initiative, we deal with two main initiatives. Then we have a flurry of professional development workshops, 2-day workshops, and then along with the Summer Institute, a 5-day workshops, primarily all designed around the educator, because what we've discovered is that so many times, and I can appreciate again what Purdue's doing, that they're unlocking some of the secrets that we uncovered too. Is if you just take a box of parts and throw it at a bunch of students, chances are they'll figure it out over time. But we've also learned too, if you throw a box of parts at a teacher, they need some help. They need to you kind of understand. Otherwise, you come back 2 months later, that same box of parts still sitting there. So we want to encourage success, and some of the ways that we kind of hedge our bets on that is to offer these workshops for our educators. But Robot Drone League is one of our other initiatives. We have a fall initiative and then a springtime initiative. Robot Drone League is that initiative, and it's played with robots and drones. The robots are programmed through a Raspberry Pi. So there's programming skills that the kids will have to develop and learn in order to program their custom built robot, and then work in unison with a drone that's also programmable. And so there's all kinds of different challenges in a 10-minute match on a field about the size of a racquetball court that's netted and protected. All the curriculum content is aligned to the NGSS Common Core ISTE standards, ITEAA, and the P21 Partnership for 21st Century Learning. And that applies to both MATE and RDL. I'm not going to show this video because I know, I'd rather open it up for comments and questions at the end, but please feel free to go to our YouTube channel and check out Robot Drone League. It says 2020 extended version, and that's because this game Dragonfly has been in the can because of the pandemic for the past 2 years. And so we're excited about that game, which was originally scheduled for January 29th at ETSU, but because of the pandemic, we've had to reschedule, and that's actually coming up next week, March 12th. So if you're in the Northeast Tennessee area, please come by and check it out. It's gonna be a lot of fun. We'll have teams from Virginia, Indiana, Tennessee, Georgia, and Florida participating. Nope, I did not mean to play that, but go to our YouTube channel and check it out, Dragonfly. Which brings up our next seasonal challenge, which is Bermuda Triangle. Some of the cool things that we're doing with this, we're actually working with a couple scientists out of Woods Hole Oceaneering and Oceanographic Research Facility to plan and release our Bermuda Triangle Challenge May 1st of this year. The cool thing about Robot Drone League, yeah, you got robots and drones going at it for 10 minutes, but there's also 2 television screens that are 180 degrees out from each other to where the other team can't see it. So they have to purposely or intentionally fly their drone in front of that screen where a STEM question and problem is going to be displayed, and the team has to figure that STEM question out for points. They have to come up with the right mathematic computation or the science related answer or formula. And so it's pretty cool to watch these kids go through it. Once they get the question right, they can progress to another question. So I think in one of the regionals that we had in December, there was one team from Tennessee that they knocked out just from STEM questions alone over 600 and some odd points. That is unbelievable. So anyway, that's Bermuda Triangle, which is coming May 1st. Now that season again is a fall season. So that starts, even though we released the game in May, that season typically starts the first weekend in September and then culminates with regionals in December and a championship at ETSU in January. Here's our 2-day workshops. We have introductory, no experience required for our workshops. We're going to bring you in and we're going to take you from scratch and show you how to build all these robots and code so that you can take these back and let your students be able to do it. We're the firm belief that we steer away from the Pinewood Derby syndrome, meaning that we don't want the adults competing. We want the kids to compete. And so, but again, we think that it's essential that the educators, feel comfortable. That's why our workshops are educator only. Look at the MATE website, the MATE workshops as well on those dates. Very affordable, and you actually get to take home a kit of parts with you back to your classroom to show your students. Our Summer Institute series, these are really important because now we're branching out. We still stay with our staples of those extracurricular after school programs, RDL, and that summer workshop is July 11th through the 15th at Valley Brook. It's ETSU Valley Brook there in Johnson City, in between Johnson City and Kingsport, Tennessee. And then we're bringing in a 3D printer educator workshop where you actually take home the 3D printer. So the price includes all the parts that you would need and the equipment, which if you go into MATE, now we have an advanced educator workshop. This does require at least one season as going through the introductory level, maybe as a middle school. And now you want to up your game to a Barracuda kit, which involves more sensors on the actual control box. So we want to make sure that you have a fundamental experience or some, just some past history with MATE before we bring you into that. And the fourth one up there is FarmBot, which is a actual farm bot that you'll actually put together and actually develop it over a garden bed. And it weeds, it seeds, it waters, it takes video. It's pretty cool. We see this, we've already got a lot of interest from our ag science folks that are looking for that classroom technology to really increase what they're doing in the greenhouse, if you will. A lot of our work, and this is very interesting, a lot of our work takes place through interns. We have high school and college age interns It fluctuates during summer. Obviously, we go up with our summer camps and our STEM camps. But throughout the year, we average around 15 interns that work for Streamworks. And a lot of the documentation that you'll see at our YouTube channel comes from our Streamworks studio. So we have a teleprompter, the green screen. They do interviews with the presidents and colleges and different guests and VIPs and subject matter experts. But these are all interviewed by our interns. So when you get a chance, please go to our Streamworks Streamworks Education YouTube channel and check out some of the work they do. They show the teachers, how to put the chassis together, or I should say the teams, how to put the chassis together or how to program that Raspberry Pi, just as a resource library, because we want to see, like I said, these events are a culminating experience for a lot of these teams. But when the kids are getting prepared, we want them to have all the fundamentals of how to program a robot or how to build, or maybe do some CAD and learn how to just put pieces of PVC together. And then they can explain to the engineering panel or the judges, hey, this is how we CAD'd up our system. Now we're using applied mathematics. And we want to show how to get into these CAD systems. Maybe it's just sharing free resources too, like Onshape or Fusion 360. This is, I had to slide this one in here. We have been talking about this for several years now, and we really want that younger age group, that K through 5, because the field for RDL might be a little too big. Now for MATE, K through 5, we have a product called Angelfish, which is there's no soldering involved. So that might be a little bit more appropriate, more safe for those those younger hands that really don't have the grip strength. Plus, dealing with a soldering iron. Sometimes when the younger kids grab one of those soldering irons, I go through an hour's worth of safety lectures before I turn any kid loose on a soldering iron. But for that younger age group, the Angelfish does not require soldering. It's crimped on, so that might be a little bit more appropriate and safe. But RDL Junior is something that we're releasing in 2023. So we've been doing our research, and we come up with a couple good products. If any of you guys have done the Sphero balls and those programmable gyroscopes, they're coming out with the RVR, which is coming out in this August. Is a cool little machine developed by Sphero. And then of course the Tello drone, which you stick your finger in those props, it won't cut. It's very safe equipment, but that's on a smaller format. And again, we believe in, I think Dr. Striml was also talking about block coding. Man, we've got to get these kids block coding as soon as possible. So, and that's what we want to incorporate with RDL Junior. Annual challenge, which again will fall in sync with what we do. Not this year because we're bringing up Bermuda Triangle, which is more of that middle school, high school. But next year, I'll just share with you, and you guys heard it first. I don't have any pictures or anything to depict it, but we want to center the RDL challenge around food scarcity. And so we have our themes called Scarecrow. And so we've been talking to a couple of our partners through the Niswonger Foundation about doing some collaboration, with Woods Hole, that's one of them, but also MIT and BioBuilder and some of those folks. So food scarcity, Scarecrow, it's going to be a lot of fun. Showing kids, again, it's robots and drones, and it's coding, it's the mastery of skill sets developed around, hopefully creating some interest in STEM relevant careers. And for us, it's more about exposure at that age group. So all right, of course, summer camps, I think we offer those at Valley Brook there in at Streamworks. If you're interested in those, you can email me and I'll put you in contact with the program coordinator and the folks that are going to do that. That's a fun time. I think there's going to be a series of 3 camps this summer. One's going to be an all-girls coding camp, which we've done that in the past. That was super successful. All the instructors are female, and all the it's a good time. But again, our camps revolve around RDL and MATE. Let's see. I'm about to wrap it up. Again, this video here is it's a 2-minute video that we filmed a couple years ago. I keep it on there because it's really powerful. The future is unpredictable like that. And I think as community, it's where I can appreciate everyone on this phone call today, this Zoom meeting, and the Niswonger Foundation for all their efforts to bring STEM into our communities, because it is a good thing. It's a good win for all of us. And that, my friends, wraps it up for me, and I'll open it up for questions. That's my contact information, and follow us on was it Twitter, Twitter and Facebook. Yeah, I wish I were a little bit more social media savvy, but I'm not. All right, that's it for me, Law.
Very good, Dennis. Thank you. You covered a lot of ground there in a very efficient way. I like that. In fact, both Dennis and Greg did an outstanding job. I always worry as moderator, like, hey, each group has about half the time. Are we going to get there? But y'all nailed it today. I should expect nothing less out of a couple of engineers. Yeah, a couple of questions that I had for you, Dennis, that I think might help. So you talked about some different summer opportunities, and I think it might be helpful for the folks on the call to understand a little more about what the staff or the teacher professional development might look like. So if you could dive into that a little bit. And then I also think it might help for folks to understand a little bit about like what's the time commitment. So it's kind of a similar question to what I asked about Greg and his opportunities. You know, what should a teacher expect to actually invest in Streamworks over the course of, say, a semester, because I know you've got a couple of different campaigns there.
Right. So the first question, the time, for the professional educator series during the summer, it's 5-day workshops, or they're 5 days. There's 4 of them, and I can provide those dates, and those dates are available at our website as well. Those are typically 8:30 in the morning till 3:30, 4 o'clock in the afternoon. We have been known to go a little bit long. I'll give you an example. Sometimes, especially when we're building those ROVs and things aren't going as planned, as we know in robotics, it happens, believe it or not. We want you to be successful. So we'll extend out our Thursdays or even our Wednesdays to make sure that everything's working. And sometimes there's some errors that need to be debugged. Plus, we also realize that folks are coming in from out of town. There's educators, teachers give so much of themselves during the school year, and then they come and they do professional development. Well, a lot of these guys or gals are coming in from out of town, and they travel on Fridays. So we try to get you out of there a little bit early on Friday after we have like a little miniature competition or some time at the pool with your new ROV, so you can see it work. So those are our summer institutes. The 2-day workshops are primarily in the fall and the springtime. And I like to do those on Thursdays and Fridays. Now, we just had one last week on Friday and Saturday at Streamworks. So sometimes it just depends on the situation and when the educators can come. We had a kind of a backlog because of all the pandemic stuff. And so we had to have multiple workshops. And then some of the educators asked if they could come in on Saturday. And we said, sure, why not? Time frame or time commitment. Like everything else, there's going to be a nice little chunk of time, depending on which initiative you're involved in. Some of our teams convert between MATE and RDL. They just go back and forth. Some teams only do MATE, and some teams only do RDL. Here's what I say: if you got a competition like on March 12th, and please feel free to come talk to some of the coaches and the teams and ask them what their time commitment is. A lot of it's going to be based on, what the team, some of them, they're pretty, they're every day, which I don't recommend. You might get some kids that get burned out on it, but what I do recommend is at least one afternoon per week, just to have team meetings. Maybe the closer you get to competition, maybe that goes up to 2 weeks. When I was coaching, a Tuesday and a Thursday seemed to work well, an hour and a half after school. Maybe the occasional Saturday. Kids love to come work on robots on Saturday, especially the closer to competition. Now, we'll say if you've got a team that's involved in the World Championships at MATE, which they're going out in June to California, you're probably going to want some of those Saturdays and pool time, and even maybe the Friday afternoon from 3:30 to 4. So it varies, But again, I like the approach of, maybe a balanced week, maybe where you only have like one after school robotics meeting, and then of course, mixed in a little bit with others in order to prepare for the competition. So is that kind of what you were looking for, Law?
I think so, yeah, and
Okay.
it might help folks to know too about, for the summer professional developments, and then for the 2-day ones during the school year, those are geared towards leading mate or RDL, or are there also some in classroom crossovers that come along with that?
Primarily the summer institutes, we found that if we can bring all the teachers to one location there at Valley Brook and at ETSU, that seems to work really well. We give you a certificate for professional development. Now, we have done satellite trainings before. We will come, let's say, up in Virginia, we had, I think it was 12 teachers. Instead of paying for all of them to come down and down to Streamworks down at Valley Brook, and pay for hotels, we just pay for the hotel room for a couple instructors to go to them. Same thing in Indiana. For different aspects or different scopes of our program, it just depends. What makes sense. Now we have had some of our instructors actually go to schools and help troubleshoot and debug problems after school. Maybe a team's having a little bit of a tough challenge, so we'll deploy a couple of our interns if it's within reason. Some of our events, like the Mid-South Regional over at the University of Memphis, we went over and helped facilitate and train those volunteers that were coming up to be able to host their own mate competition and RDL competitions later on. So we try to look at every situation and every event differently, and try to put together a solid game plan on what works and what helps that community. Because at the end of the day, what we firmly believe in is that STEM education is there for all communities. And if we can share our secret sauce with all communities and how we do that, and how, maybe we can provide as many resources that we have to offer as, whoever's interested in listening to us, then yeah, we want to help. And so that's kind of the bottom line from us. We'll figure out a way.
Well, that summed it up there. So I just wanted to underscore, and you've heard it from both partners today, but I mean, there's an immense amount of flexibility. So we always like to ask the question at the foundation, and we found that all of our partners do as well. How can we do things? Not, well, we can't because of X, Y, or Z reason. And I think you'll find all of our partners are extremely supportive and flexible, and you hit it on the head there, Dennis. So we did have a question about where the trainings are locally here in Northeast Tennessee. So you've mentioned Valley Brook campus several times. It is an ETSU facility and has been for a while, but it is not the most well-known ETSU facility. It is not like in downtown Johnson City or anything, right. But it is actually pretty easily accessible. So I dropped the address in there in the chat. If you Google Maps it, you can find it pretty easily. It's off of exit 10 on Interstate 26.
I believe it's 122 Pickens Road.
Oh, is it? Okay.
Yes, I believe so.
122 Pickens.
Yeah, sometimes that address
comes up on Google.
Yeah, it shows up in Kingsport, Tennessee. That is the mailing address. But then if you go to the post office, they'll tell you it's Jonesboro, Tennessee. I would absolutely Google map 122 Pickens Road, Kingsport, Tennessee, and look at the map, because what's going to happen, you're going to get off exit 10 at I-26, and you're going to go down Eastern Star Road, and it's going to be a residential area and you have to pick a right down on Winchester, and you just keep going through the stop sign, and then all of a sudden this huge complex shows up, and there's gate guard. Usually the gates open Monday through Friday, so you should be. But if you want to come out and visit, take a tour, please, we welcome you to come out there. Valley Brook is an old Eastman research facility that was donated to ETSU. It's a really cool facility that they brand new construction back in the late 80s, I believe. And so they gifted it after 2 years of being in the animal science nutrition business. They gifted it over to ETSU. So it's a pretty cool place.
And I wanted to mention it because it is pretty centrally located for much of our region. It's a little further away for some folks than others, but it is a place that we will probably be doing some other STEM.LD activities at over the course of the grant. So If you don't get to Valley Brook now, you might end up there later on. Any other questions for Dennis? If not, I'll give another couple of minutes here for that. And while we're waiting, I will go ahead and do a, let's see, I'm going to go ahead and share my screen for those folks on the recording. Brashay or somebody on the Nicewanger team, if you would just drop the link to the attendance survey in there. And then I would also ask if somebody could drop the STEM.LD website link in there. So we do have a central website where we actually keep all these presentations, so you can go back in and watch them at any point. Any supporting documentation also lives on there. Our public facing calendar. So, you know, when Greg has things from Purdue that are scheduled that are going to be happening after school or during school or whenever those are taking place, all the different dates for the professional developments and the other competitions that Dennis mentioned, there's a public facing calendar on the site, and we keep that updated very regularly. We'll be promoting events from that calendar. Anytime you're wondering, hey, what's happening with STEM.LD, that's a great place to go and reference. So all of that is at the site link that you can see there in the chat. John, thank you for dropping that in there. So in addition to making sure that you fill out your attendance survey, that just takes a second, I would also make sure that you go check out STEM.LD's website so you can stay on top of things. We're always adding new things on there. And so it's a good place just to sort of have bookmarked or saved so you can go back and reference it. Couple of last points. So we have one more showcase tomorrow. That will be our folks from ETSU and then from BioBuilder, who Dennis teased a partnership with. And you may see that there are actually a lot of collaborations going on between our partners. So we're very excited about some of those cross-disciplinary things that are happening. After that, so our showcase tomorrow will be at the same time. It'll actually be the same Zoom link. After that, you are able to go and so starting on Wednesday is when we'll actually start our deep dive partner selection. So there'll be a form and there'll be a process. We'll send out an email to all of our lead contacts at the various schools. Once you've had a chance to have somebody at your school watch all of the showcases, then you will be able to start that process of actually selecting your deep dive partners for the school year. Keep in mind, not everybody has to work with any given partner. So there might be some folks interested in working with Purdue, for example, and then other folks that want to work with Streamworks. That's perfectly fine. Every school does things a little differently. Some folks try to go all in on just a handful of partners or a couple of partners, and that's okay too. We do have a goal of having 80% of your STEM teachers at your schools partnered with a partner that fits them and makes sense for them. So that's a number that we're kind of shooting for. We'd love for it to be 100%, but we at least would like to see 4 out of every 5 or so teachers partnering with our partners like Purdue and like Streamworks. And again, just remember that all of this is taken care of financially through the STEM.LD grant. So if you're interested in those professional development opportunities, you have access to those free of charge through us. In addition, we're actually sponsoring a lot of the out of school time activities as well. So your students have the opportunity to take advantage of those through STEM.LD also when you create those partnerships. So any last minute questions about anything that I just shared or the attendance form or anything for Streamworks or Purdue while we've got them here live? Going once, going twice. All right. Well, thank you very much for being here today. We really appreciate it. And thanks to Greg and Dennis for sharing their information. And we will see you all very, very soon. Thanks.